Okay, carbon chain length. So in organic chemistry, we're looking at chemicals that have got carbon bonded to itself. Remember? Okay. So this has got 3 carbons, one's got 6. Right? Let's say we had a, for some reason you wanted to poach an egg in an organic chemical. I don't know why you would. Theoretically you could do it. I wouldn't eat it, but you could do it, right? So when you poach an egg, right, you put water on the stove and you fire it up. Water's 100 degrees Celsius and then it will start to boil, okay? If you put an organic chemical on the stove and poach an egg in it, so you're boiling it, and it's this big, 3 carbon chains, right? Carbon chain 3, or if it was this big, which chemical do you think would boil quicker?
Small one.
Yeah, the small one, right? Makes sense? Because it's smaller. Okay? Right, there's less bonds in it that need to have the amount of energy to reach that boiling point. So as a general rule, smaller organic chemicals have lower boiling points than bigger ones. So if we wanted to write a concluding statement about carbon chain length and boiling point, we could suggest that as the carbon chain increases, the boiling point increases. Yeah? It's a general rule, doesn't always apply, but most of the time it does. You see B dot P means boiling point. Sometimes chemists are lazy, right? They use B dot P instead of boiling point, that's what it means. So as carbon chain length, as it increases, the boiling point increases, okay? Only if they've got identical functional groups. So what that means is if you've got a really small alcohol, right, you'll have a low boiling point. As you make the alcohol size bigger, the boiling point goes up, okay? But what you can't say, because it's a general rule, what you can't say is if we had, for example, like ethanol, right, 2 carbons as an alcohol, and we had ethanoic acid or vinegar, acetic acid, 2 carbons with an acid functional group. So we've still got 2 carbons and 2 carbons. We can't compare their boiling points based on their chain length because the group that they come from is different. Okay, so we only compare boiling points. Can only use carbon chain length to compare boiling points of chemicals in the same group, not cross groups. It's too hard. It's too difficult. Okay, so I should write that there. Identical groups. So carbon atoms, they weigh about 12 grams per mole on your periodic table there. That's the molar mass. So if we increase the carbon chain length, right, say 12 plus 12 plus 12, you get 36 for your carbons there, but this one will be times, this will be 72. So you can also say that as the carbon chain length goes up, so does the molar mass. So it weighs more.